In this video, I'm going to show you how to use the Arduino IDE to program an ESP8266 microcontroller for reading and publishing sensor data using MQTT to a HiveMQ Cloud MQTT broker. Further, I'll show you how to receive MQTT messages as commands from the cloud to activate the microcontroller output for switching on and off a light emitting diode. To begin, let us briefly look at the hardware components we will use for this demo: the NodeMCU microcontroller unit and the DHT11 temperature and humidity sensor. The NodeMCU is a small, fast and Wi-Fi capable microcontroller board that can be easily programmed in the popular Arduino integrated development environment. The board is based on the ESP8266 chip, and it has many input-output ports and various serial interfaces such as SPI, I2C, or the RS232. The DHT11 is a sensor capable of measuring the relative humidity and temperature of the surrounding environment. It consists of 3 pins, 2 for power, and 1 is a signal line for transmitting the sensor data to the microcontroller. Next, let us look at how to wire up the hardware components for this demonstration. As shown in this diagram, the VCC of the DHT11 goes to +3 volts of the NodeMCU, the signal pin of the DHT11 goes into the digital pin GPIO2 of the NodeMCU, and the ground pin of the DHT11 goes into the ground pin of the NodeMCU. Further, the LED is connected to the NodeMCU digital pin GPIO5 through a resistor. Since I'll be publishing MQTT messages from the NodeMCU board to an MQTT broker, I need first to create the MQTT broker on HiveMQ Cloud and then get the broker details that I can use in my Arduino code. I'll go to the HiveMQ website and select Cloud on the menu. When I do that, I'll get the HiveMQ Cloud page and I'll click on the Try Out for Free button. This provides a sign-up page to create a free account that allows me to connect up to 100 devices. If you're accessing the HiveMQ Cloud portal for the first time, you'll need to provide an email address and password and follow the simple steps to confirm your email and create your account. When your account is successfully created, an MQTT broker cluster will also be automatically created for you. You will need to begin by setting up credentials to allow devices to connect to your MQTT broker. So I'll define my username and password. And then I'll click on Add. When I click on Clusters, I'll get a list of my MQTT broker clusters, and since I just created this account, I only have one. So my MQTT broker setup is ready, and now I just need to get the cluster URL, port number, and access credentials for use in my Arduino code. And if at any point I wish to update my connection credentials, I can always log into my portal, click on Manage Cluster, and select Access Management. Next, I'll start building my software on the Arduino IDE. To program my ESP8266 NodeMCU board, I need to use the Arduino IDE as previously mentioned. You can download Arduino IDE by going to the software downloads page of their website. I will download Arduino for Windows and then I'll install it. After installing the Arduino IDE, you can program various Arduino boards. However, to program a NodeMCU board instead of an Arduino board, you will need to add a package to the IDE's board management system. To do this, I'll go to the File menu and select Preferences. Then under the additional boards manager field, I'll enter this URL. And then I'll click OK. Next, I'll go to the Tools menu and select Board, followed by Boards Manager. Then I'll look for ESP8266. And then click on the Install button to install the ESP8266 package. Now I'm ready to start programming my NodeMCU and other ESP8266 modules using the Arduino IDE. Next, I need to specify the ESP8266 board I want to program in the Arduino IDE. So I'll need to connect my NodeMCU board to my PC using a micro USB cable. And while I do that, I need to have my Windows Device Manager open. As soon as I plug in my board, a new COM port appears on the Device Manager. Looking up Windows Device Manager like this is unnecessary, but it can help you troubleshoot if you have problems with your USB drivers. You can usually access the COM port by going to the port menu item under Tools in the Arduino IDE. To select my board for programming, I'll go to Tools, followed by Board, and then under ESP8266, select this NodeMCU ESP12 module. Before moving directly to coding, I need to install the required libraries. To read sensor data, you must install the DHT sensor library available from the Arduino Library Manager. So I'll navigate to Sketch, Include Library, Manage Libraries, and then I'll search for DHT, and then choose to install one from a number of DHT libraries. Next, to be able to publish MQTT messages to my HiveMQ Cloud MQTT broker, I also need to add an MQTT client library. In this demo, I'll use a library called PubSubClient. Again, there are many to choose from. I'll add this one from Nick O'Leary. Now we can start developing our code. Let us go through the complete code for sending and receiving MQTT messages using NodeMCU on the Arduino platform. First, I import the required libraries into my Arduino code. Next, I declare GPIO2 as the pin on which my DHT sensor is connected, and I also declare GPIO5 as the pin on which the LED is connected. After that, I declare variables for holding my Wi-Fi connection and HiveMQ Cloud MQTT broker details. Then I make sure to initialize a secure Wi-Fi client connection, create an MQTT client using PubSubClient library, and attach it to the secure Wi-Fi connectivity. And also here I declare variables for buffering MQTT messages. And then after that, I've got a variable for holding a root certificate that allows my client to connect securely to the HiveMQ Cloud MQTT broker. Then I declare a function that I'm going to use to connect to my Wi-Fi network. After that, I have a function for connecting to the HiveMQ Cloud MQTT broker. Next, I have a callback method for receiving MQTT messages and switching the LED on and off. After that, I have a method for publishing MQTT messages to my HiveMQ Cloud MQTT broker. And then I have the default Arduino setup method where I set up my DHT11 sensor and LED and enable my certificate for secure connection and set up Wi-Fi and also create instances of my MQTT server and callback methods. Finally, I have my main function for executing the application logic. Here, I first connect my MQTT client to the HiveMQ Cloud MQTT broker if not already connected. Then I read temperature and humidity values from the DHT11 sensor and serialize it, including device ID and site ID properties, into a JSON object. After serialization, I publish the JSON string to my HiveMQ Cloud MQTT broker under the topic ESP8266 _data. And then I repeat the process every 5 seconds. Next, I will deploy this code onto my microcontroller board. Now that my code is running and I'm publishing data to the HiveMQ Cloud MQTT broker, I can use an MQTT client application such as mqtt.fx to subscribe to the broker and view the data. When I open my mqtt.fx application, which is already connected to the HiveMQ Cloud MQTT broker, and subscribe to the same topic, I can see the data coming through. This means I'm successfully publishing data from the NodeMCU to the HiveMQ Cloud MQTT broker using MQTT. Now I will publish an MQTT command to switch on the LED light from my mqtt.fx application by publishing the value of 1 under the topic LED_state. When I do that, you can see the LED light switch on. I can also switch the LED light off by publishing a value of 0. So I have successfully demonstrated how to send and receive MQTT messages from the Arduino platform to HiveMQ Cloud MQTT broker using NodeMCU based on the ESP8266 chip. Thank you for watching, and for more videos like this, please check out the HiveMQ YouTube channel.